Welcome to Cadence Design Systems Omnis Tutorial Tuesday, where we show you how to use our fully integrated environment, Omnis, in short videos of a few minutes. In this video, I will show you how to define connections in and between domains. The connection management tool is available from the domain context and is used to define matching, full non-matching, and rotor-stator connections between domains. Here is an example with two domains, an impeller and a volute, between which we want to define a connection. In the domain context, click on the Connection Management option in the pie. Click on the Create button to add a new connection. Select the created mesh connection definition and double-click to rename it if necessary. Then, define the mesh connection type and its parameters. The available types are matching, full non-matching or FNMB, and rotor-stator. You can define the FNMB and rotor-stator connections either before or after creating the mesh, but matching connections should be defined before generating the mesh. In this example, we want to define a rotor-stator connection because the two domains have different periodicities and different rotation speeds. Then, add geometry boundaries to the left and right sides of the connection by expanding the tree and adding the corresponding boundaries. Whether you interchange the boundaries in the left and right sides will not influence the results. Another way to define the connection is to select all the boundaries of both sides of the rotor-stator interface in the family tree and clicking the Create Boundary Connection icon above the family tree. The connection is created automatically, but make sure that the left side and the right side contain the correct boundaries. Once the connection is defined, don't forget to switch the boundary condition type to rotor-stator for all the patches that are part of the connection. Note that when the two domains are part of a turbo configuration, the boundary types are set automatically, and this step can be skipped. This is the case in this example, where rotor-stator interfaces are automatically defined between adjacent rows. There is one important limitation you should be aware of when setting up a rotor-stator interface. When one side of the rotor-stator interface contains an unstructured mesh, a single patch that covers 360 degrees is not supported. At least two patches should be defined. This is the case with the volute patch in this example, which has been split into multiple patches with the option to capture the surface edges activated in the mesh context. Going back to the different connection types, let's have a look at the matching option. This option is used when the boundaries on different sides of the connections belong to different domains. Note that if viscous layers are inserted on one side of the connection, Omnis will automatically insert viscous layers on the other side of the connection. Let's have a look at an example with two cubes, each belonging to a different domain. On the first cube, the top and bottom boundaries are refined and viscous layers are inserted. On the second cube, only the initial cell size is imposed with no additional refinement. After the mesh is generated, you can see that the connection between the two cubes was kept matching by adding refinements and viscous layers in the second cube. Note that for CHD computations, the matching connections between solid and fluid domains can be automatically created, but this is the subject of a different video. The last connection type is the full non-matching, or FNMB, which connects several patches between different domains or inside the same domain with non-matching boundaries. The domains to connect can be solid, fluid, or a mix of both. The type of FNMB can be set to default, periodic, or repeated. The default option is used when the FNMB should only be computed where the two sides of the connection overlap. A periodic FNMB is used when one side of the connection should be translated or rotated to overlap with the other side. In case of rotational periodic FNMB, define the rotation axis direction, the anchor point, and the periodicity. In case of translational periodic FNMB, define the translation vector. A repeated FNMB is used when a number of repetitions need to be set in order to fully cover one side of the connection with the other side and its repetition. Let's have a look at some examples. If a turbo configuration contains a row and full non-matching ZR effect, check the connection manager and set the predefined connection as an FNMB with the option default or repeated by rotation, depending on whether the ZR effect block covers the same circumferential location or not. In this first example, the ZR effect is aligned with the row and the connection should be defined as default. But if we activate the repeated FNMB option, the ZR effect is shifted circumferentially from the row and the connection should be defined as repeated by rotation with 2 repetitions. Note that whatever the type of FNMB, a patch can be contained in only one side of a single FNMB connection. Once the FNMB and rotor-stator connections have been defined, they will be computed when running a simulation containing these domains. If the connection is properly computed, a check mark will appear in front of the connection name in the simulation context and in the domain context connection manager. Thank you for watching. If you liked this video, be sure to click the thumbs up button to subscribe to our channel for more upcoming videos like this. If you have any questions or suggestions for future videos, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a great Tuesday.